Hello all and welcome back to the Basics.Academy channel. Let's dive into our first hash map hash set problem, finding the difference of two arrays. Let's go back to our AI Socratic interviewer, paste the problem statement and solve it in an interview style format. Before we solve the problem, let's cover the basics of set and map in JavaScript. What is a set? A set is a collection of unique values. On adding duplicate elements to the set, it silently ignores them. The insertion order in a set is preserved. All operations on a set take big O of 1 time on average. The different operations involve create, add, hash, delete, and size. One-liners worth memorizing. In order to remove duplicate elements from a given array, create a set of that given array. All the duplicate elements will be removed. Modern runtimes support direct set operations. The different operations are union, intersection, difference, symmetric difference, is subset of, is superset of, and is disjoint form. After covering sets, let us go ahead and have a look at JavaScript map. What is a map in JavaScript? A map is a key value store. It is recommended to prefer map over a plain empty object when keys are in simple strings. Because when you use map, it preserves the insertion order, and when you want a real big O of 1 time to get the size of the map. The different operations include creating a map, setting or updating values inside the map, getting a value from the map, checking if the value exists inside the map, deleting a value from the map, getting the size of the map, and at last clearing all the entries from the map. Why map beats an empty object? Because keys can be of any type, numbers stay numbers, not coerced to strings. Insertion order is preserved when you use map. Dot size always returns in big O of 1 average time. No prototype key collisions. How can you iterate maps in JavaScript? There are 3 ways. If you need to access the key values, use the first for loop for const k comma v of m. If you want only the keys, const k of m dot keys. Only the values, const v of m dot values. Must know idiom in case of frequency counter. Whenever a problem statement comes which asks to take into consideration the frequency counter, this must be memorized. While setting the value, check if the value exists. If it doesn't exist, return 0, add that to +1. The OR 0 handles the missing key case. If the problem expects to return an array, there are 3 ways in which you can return an array: using array.from, calling m.values, using the spread operator, calling m.keys, using only the spread operator with the map entries. Let us switch back to our AI Socratic interviewer. Here we have our AI Socratic interviewer. Let me paste the problem statement. Find the difference of two arrays. Let me copy this. 2215, find the difference of two arrays. Paste the problem statement here. The approach that we will follow is we will make use of set and its operations to get to the solution. We are given two zero-indexed integer arrays, nums1 and nums2. Return a list answer of size 2, where answer 0 is a list of all distinct integers in nums1 which are not present in nums2. Answer 1 is a list of all distinct integers in nums2 which are not present in nums1. Note that the integers in the lists may be returned in any order. Return value is answer array of size 2. Answer of 0 is equal to list of all distinct elements, and answer 1 is equal to list of all distinct integers in nums2 which are not present in nums1. We will convert both nums1 and nums2 to a set. This will automatically remove all the duplicate elements. Then answer of 0 will be set A and the difference of set B, and answer 1 will be equal to set B taking the difference of set A. JS set, here it is JS set. It's only dot difference in A, not in B. The method is only difference, not difference of. And at last we will return answer. Are there any constraints? Nums1 dot length and nums2 dot length is greater than 1, less than 1000. Nums1 of I, nums2 of I greater than minus 1000, less than equal to 1000. Hit enter.
Welcome back to the Basics Academy. Today we are tackling LeetCode 2215, find the difference or two arrays. It's an easy one, but let's make sure your thinking is airtight before any code goes down. Let's start with understanding. In your own words, what is this problem asking you to produce and what exactly does the output look like?
It is asking to produce an answers array with two elements, where the first element is the total number of all distinct integers, total number of all distinct integers from nums1 and not present in nums2, and the second element is the total number of all distinct integers from nums2 and not present in nums1. This is a straightforward set difference problem. First,
You said total number twice. Let me push on that with the examples. In example 1, nums1 is 1, 2, 3, nums2 is 2, 4, 6, and the output is, if answer 0 were a total number, what number would it be, and does that match what you actually see in the output?
yes, total number of distinct elements. Let me just read the question once again. Answer 0, okay, is a list of all distinct integers. That means answer 0 is an array. Got it. Got it. Answers 0 is a list and not only the size of the list. Same goes with answers of 1 as well.
Exactly right, their lists not counts. Now let's nail down the input-output contract. What are the types and value ranges of your inputs, and what's the precise shape of the output?
Types is integers. Range of inputs is and precise shape of output is answers list 1, list 2.
Good, you gave the value range or the elements. There's another constraint about the array lengths. What is it, and does it tell you whether either can ever be empty?
No, the array cannot be empty.
Correct, at least one element each, so neither is empty. Now the habit we are building: enumerate the edge cases out loud before coding. What edge cases or tricky scenarios should your solution handle here?
Edge cases might be both the arrays have exactly one element. In that case, the answers can return a response of this type.
Good, that's the case where everything overlaps and you get two empty lists. There's one word in the problem statement, repeated twice, that hints at another scenario. Look at example 2 with the repeated threes. What does the word distinct force you to handle?
The word distinct force to handle only unique values and ignoring the repeated values.
Right, did you pay within each array, so a value appears at most once in the output. Now, before the clever approach, what's the brute force way to do this? Don't optimize yet, just describe the most obvious method. Walk me through it whenever you're ready.
What's the brute force way to do this? The brute force approach would be iterate nums1 array and start pushing its element into another array or set data structure. The condition for pushing will be to check the element should not exist. Only then push, else ignore. Same as 1 for nums2. Step 1 and 2 deduce the array. After deduplication, find the difference of nums1 and nums2, assuming we have removed duplicates and added the distinct elements to nums1 and nums2 array. The names will be different in implementation, or the arrays will be different in implementation. How exactly can we find this difference? We iterate nums1 and check if nums of I is present in nums2 of first. We iterate nums1 from I equal to 0 to I less than nums1 dot length. For each I equal to 0, we iterate nums2 from j equal to 0 to j less than nums2 dot length. If nums1 of I is not equal to nums2 of j, We push that to list 1. List 1 will be stored at answer of 0. The above 3 steps will be repeated for nums 2 as well. At last, we push list 1 and list 2 inside answers array and return those and return the answers array.
I want to stress test step 4 before you trust it. Let's trace one specific element. Take the value 2 from nums1 which is present in nums2, so it should not end up in list 1. Walk your inner loop over nums2 which is 2, 4, 6 for that value 2. At j equals 0 you compare 2 versus 2. At j equals 1 you compare 2 versus 4. With your rule, if nums1 I is not equal to nums2 j, push what happens at j equals 1 and is that what you want?
Got it. So the correct condition will be you are iterating nums1 and you want to check, you want to find the difference. Difference is distinct integers in nums1 which are not present in nums2. Distinct integers in nums1 which are not present in nums2. In case of 1, 2, 3, so here we have 1. 1 is present in nums1 but it is not present in nums2. Okay. The condition is nums of I not equal to, I think we should not push it. So what will be the correct condition? If nums1 of I not equal to nums2 of j, don't push it. 1 is not equal to, in this case, nums of I, let us say I is 0, it is at 1, j will start on 0, 1, 2. So here 1 is not equal to 2, 1 is not equal to 4, 1 is not equal to 6. In this case, as per the if condition, 2, 4, 6, 2, 4 and 6 will be pushed, which is incorrect. So the correct condition will be if nums of I common equal to nums of j, both are equal, don't push it. No. Nums of I is 1. The correct check would be nums1 of I not equal to nums2 of j. Here we will use a count variable, count plus equal to 1 after the for loop if count is equal to nums2 dot length, then we push nums1 of I into list 1.
That's the fix. The value match is not present only if count hits nums2 length. One subtle thing about that count variable, where do you declare and reset it? So the trace stays correct across different I values.
Count will be declared after the for loop starts. So at each new value for I, it will be reset to 0.
Exactly, declared at the top of the outer loop body, so it resets each time. Now give me the time and space complexity of this brute force version.
Time and space complexity.
Think about the nested loops for the comparison step.
Nested loops. One comparison. Time complexity will be big O of n square, and space complexity would be big O of n plus m, since we will be creating two different arrays to store the distinct elements, and all elements can be distinct in the worst case.
Reasonable. More precisely, it's O of n times m for the comparison, and note your dedup step, checking if it exists in an array, is also quadratic. Space O of n plus m is right. So what data structure makes both the dedup and the lookup dramatically faster, and why? What's the structure?
Set makes the dedup and lookup faster because it cannot have duplicate elements, which we need for this current problem. Also, all operations on a set, such as set has delete, then add, take, echo of 1.
Exactly. Set gives you free dedup plus O of 1 membership checks. Walk me through the full optimized algorithm using sets, start to finish. Take me through it.
Create set A from nums1 array. Will create set B from nums2 array. Step 1 and 2 ensures no duplicates are present. Use set A or answer of 0 is equal to set A dot difference set B, and answer of 1 is equal to set p dot difference with set a. Return answer.
King 1 correctness check. What type does SETA dot difference set return, and does that match the output shape the problem demands?
It returns the set.
What does it give you back?
It returns the set. The output has to be returned using the spread operator. Insert 0 equals this. Likewise, we will calculate answer of 1 as well.
Spot on. Spread the resulting set into an array. Last thing before you code, time and space complexity of this optimized version.
Time
Go ahead.
complexity is big O of n. Space complexity is also big O of n. Space complexity is big O of n because creating two different sets from array, worst case the array can have on distinct elements.
Good. More precisely O of n plus m, since you touch both arrays, but O of n captures it. You've done the full pre-flight. Green light, code it up in JavaScript and tell me when you're done.
Let's code it up. Step 1, create set A from nums1 array. Const set A is equal to new set and pass in the nums1 array. Likewise, step 2, create set B from nums2 array. So const set B is equal to only set pass in nums2 array. After this, step 3, answer of 0 is a list of all distinct integers in nums1 which are not present in nums2. Let us define an answers array. Const answers equal to of size 2. We will use let here answers of 0 is equal to set A dot difference is set B. Step 4, let us copy this. Answer of 1 is list of all distinct integers in nums2 which are not present in nums1. That will be answers of 1 is equal to stud operator set B difference set A. Step 5, return answers. Return answers. Just copy this, go back to AI Socratic interviewer, paste the code. Let's see what it responds. Misleading array initialization.
Before I give the full review, trace one line for me. Right after let answers equals bracket 2 executes. What is the length of answers? And what's sitting at index 0? What does that array actually hold at that moment?
Okay, got it. Add the array at index 0 holds the element 2.
Right, so here's the interesting part. Does that stray 2 actually corrupt your output, or does it survive? Reason through what happens at the two assignment lines that follow. Talk me through it.
I will have to cross check that with array initialization because if JS considers it to be a dynamic array, then we should have used push instead of index based assignment. The current code will fail. This is a guess.
Small nudge, JS arrays are dynamic. Yes answers index 0 equals list 1. Does that add a new slot, or override the value already sitting at index 0? Which is it?
Override the value already sitting at index 0.
Here's the verdict. Your solution is correct and optimal, O of n plus in time age space. The only real smell is the let answers equals bracket 2 line, which works only by luck. Your communication and edge case enumeration was strong this round. Full written review is on screen.
Perfect.
Score 8.5 out of 10. One concrete improvement for next time: initialize data structures with their literal correct value, never a placeholder you intend to overwrite. Bracket 2 to mean size 2 is exactly the kind of misleading scaffolding that survives by accident and costs you when a reviewer reads it. Now the closing reflection, and I want this as a back and forth. First question, what quiz in the problem statement pointed you straight at a set before you even thought about brute force? What were the giveaways?
I'll come back to this after submitting the code. JavaScript arrays. So here we have car values arrays, item 1, item 2. Existing array elements, change cars of 0, cars. Let us go back to the solution since this will be an empty array. And we'll use this as const answers. Here we will use answers.push. So this will be pushed at index 0 and second thing will be pushed at index 1. Save, let me run this. So test result are all positive. Let me submit the code. Done. So the code takes 7 milliseconds to run. Let us go back to our AI Socratic interviewer and try answering the questions. What clues in the problem statement pointed you straight at a set before you even thought about brute force? Deduplication and the hint in the question that element is present in one array and not in another array. That connected to set difference.
Exactly the two signals, distinct screens dedup and in A but not in B is the literal definition of set difference. The pattern to file away, anytime you see present in one collection but not another, reach for a hash set before nested loops. Next question. Think back to your brute force draft where push if nums1i is not equal to nums2 joule would have pushed duplicates. What would an interviewer have concluded about your process from that first bug, and what habit prevents it? What's your read on it?
The interviewer may have concluded not strong or deep thinking, not dry running the code before submission.
Fair read. But notice what actually caught it, tracing one concrete element, the value 2 through your inner loop. You don't need to dry run the whole array. Pick one element that should be excluded and one that should be included and work each through every branch. That single move catches both bugs. Last reflection question. What's the one thing you'll do differently on the next problem? Tell me.
Prior to jumping to the optimized version, think about the brute force, dry run one sample through the pseudocode
If it goes well, then propose the final solution.
That's the right discipline. Brute force first, dry run one sample through the pseudocode, then optimize. You did most of that today. The gap was carrying the trace habit into the final code, not just the algorithm. Solid session.